All right, so limit 6, this is going to be the last one that we do worksheet for. We're going to get back into the book probably next week. We might have a review day in there too, since you guys will be back in the building. But limits 6, we're going to find the limit at essential discontinuities. All right, and discontinuities, you guys know, can be lots of different things. It can be where you have a graph and it just has a hole in the graph. All right, so say the question was, find the limit as x approaches 4 from the left. All right, well, from the left on the graph, that just means we're coming along this line because this is all on the left side of 4. All right, and the closer and closer we get to 4, the closer we get to 5 here. All right, so that would be our first one. Say that we try and use the same graph. X approaches 4 from the right side. Well, we don't care about the left side anymore. We just care about this side. So we get closer and closer and closer to 4 on this side. And we're going to 5 also. All right, so you can read the graph and be able to tell that. All right, we also have one more here, which you guys know we've been practicing, where we don't have a plus or a minus here. We evaluate it from both sides. Well, when we evaluate it from both sides, it's got to be the same number. Now, obviously, we already did that, and we see that both of these numbers are the same. Okay, you can also see that from the graph. All right, it's 5 on the left side, it's 5 on the right side. That means that this would have to be a 5. All right, so that's one thing that we've done. All right, and we can read that from the graph. Now, say that we had another graph here. Say that we had, I don't know, say we have this one. We're going to go from 4 again. And then we have this one. All right, and we're going to do the same questions here. All right, now, first one, from the left side, we are not going to use that graph because I don't know what the answer to that is. All right, let's try again here. All right, that one, at least we can find the answer now. All right, so we do it, we are going x as x approaches 4 from the left side here. So we're coming along on the left side, so that's this bottom one. We're getting closer and closer to 4, which gets us closer to the y value of -3 here. All right, so that one gives us a -3. From the right side, we're getting closer and closer and closer to 4 here. Now, when we approach it from both sides, remember they've got to be the same to be able to find the limit, and we can tell that quickly from the graph. As we approach on the left side and the right side, it's not going to be the same. So this would be a D&E, it doesn't exist. All right, so any questions on a little bit of review there? And that's just coming off of the graph. I know that, you know, most of the time we're putting the graphs away to be able to tell this stuff, and that's totally fine. But you can also tell what these limits are just by reading the individual graphs. All right, now that was one discontinuity. Another type of discontinuity here would be if we have an asymptote here. All right, I guess I should have left all this stuff because we're gonna evaluate this at the exact same spots. Now, an asymptote discontinuity, normally what that is that's going to be where we approach the line, however, normally it's some kind of curve, and we get closer and closer and closer, but we don't cross it. All right, and sometimes it'll look like that. The other side Maybe the other side looks like that. All right, so this is a graph we haven't done yet. This is an equation we haven't done yet, but we can figure out what the limit of this is. All right, if we look at this, we're asked the limit as x approaches 4 from the left. All right, so here's our 4. We know at 4, it's going to be discontinuous because of the asymptote. But as we approach 4 from the left, all right, we are getting closer and closer and closer to it. But our y value is going to keep going up as we go here. It's just going up, right? And our y value ends up being positive infinity here. All right, from the right side, it's kind of the same concept. All right, it's getting closer and closer to that 4, but it keeps growing the closer we get to 4. So this is also going to be infinity. All right, and then our last one down here, if we do it from both sides, well, both sides are going to infinity. Both of these answers are infinity. Then our answer would be infinity there also. All right, and we're going to do some equations here to be able to figure this stuff out. But right now we're just looking at the graphs to be able to see. There's also one other type of graph that we're going to deal with today. And it's stuff that we did last year, at least the graph looks like last year, where we have one that looks like this and one that looks like this. We did quite a few of these last year. All right, now we're going to evaluate it at the same points here. All right, so if we look at the limit as x approaches 4 from the left side, we're getting closer and closer to 4 from the left. Well, that's going to, just like the last one, that's going to go up to positive infinity. All right, from the right side, that's going to be this other side. We're going to go down. And that's going to keep dropping the closer we get to 4. So that would be negative infinity. All right, now this bottom one, to evaluate it from both sides of 4, to evaluate it as x approaches 4 from both sides. All right, to get an answer, remember these two have to be the same. Okay, it's the same concept as what we did before. These two are not the same, so the limit doesn't exist. All right, and these last two graphs that I just showed you, this one that's here right now, and the one where they were both going, both of them were going up, that's what we're going to work with today. All right, so let's go ahead and jump into this. All right, now we're not going to graph out every single one of these, but we are just to get you used to this a little bit. Evaluate each limit. You may use the provided graph to sketch the function. All right, the first one, limit as x approaches 2 from the left of negative x squared over 2x minus 4. Now, rule of thumb for limits, all right, most of the time, we are going to evaluate the limit at a discontinuity. All right, most of the time they don't actually just put a number there where it actually works. All right, so, but we already know that our very first step of limits is to plug it in. So we got to plug in this 2 and see what happens here. If we get an answer at 2, then that's what our answer is. All right, so that's still the case. So we've got 2 squared is 4. I'm putting the negative up on top. And then 2 times 2 is 4 minus 4. There's our 0 on the bottom, which tells us that we've got to try something else. Okay, and for this one, that means at least for now, we need to make an XY chart. All right, now what I would test this out at first is I would put my 2 in there, and we already know that that's undefined. All right, now technically right now we don't know if this undefined spot is a hole in the graph or if it's an asymptote. We're going to have to test that out with plugging in some other points. So what I would do is I would do 2 above and 2 below, at least for now. All right, and this is just to get the shape of the graph. All right, you're not going to do all 4 of these every single time. All right, so for 3 here, if we put a 3 in there, let me get rid of this. We would get a -9 on top over 2, so -4.5. If we put a 4 in there, that'd be -16 over 4 would be -4. We put a 1 in there, we'd get -1 over, looks like negative, how about 2 minus 4 would be -2. So that would be 1/2. And then for a 0, we would get 0 over -4 would just be a 0 here. All right, so hopefully this will give us enough information to be able to tell what's going on here. So we've got at 3, we're down at -4.5. So right there. At 4, we're at -4. All right, at 1, we're at 0.5. And at 0, we're at 0 here. All right, now that's not really telling us a whole lot. All right, I mean, we know that there's a good possibility that this is going to be an asymptote based on what's going on here. All right, not going to be a hole in the graph at all because there's no real good way to connect up those 4 points. All right, so since there's an asymptote, what we can assume, and we can make this assumption here, because for the left side, as it gets closer and closer and closer to 2, you can tell that it's starting to go up. So if you don't want to just guess that, well, maybe we put in a 1.5, and the math is going to get kind of messy here. 1.5 squared is 2.25 divided by, this would be, that'd be a 3 minus 4 would be a -1. So this would be 2.25. All right, so then we would come up here, and then you can definitely start to see that hyperbolic shape here. All right, so it would look something like that. We don't really know what this part turns into, but we don't really care either. All right, on this side, because as right side, the closer and closer we get to 2, we can assume because it's going down that it's also going to continue to go down here the closer you get to it. All right, so this one says evaluate it from the left. So based off our graph, we can tell that this is going to start shooting up here. So our answer then would just be the limit as x approaches 2 from the left of -x squared over 2x minus 4 is positive infinity. All right, any questions with what I was talking about there? It's a little bit more of a, it's more of a concept other than like a factual rule that we're going to follow here. All right, now, do we have to graph out every single one of these? No. All right, for the second one, I'm not going to graph it out, okay? You guys can kind of see that it's going to either be some kind of hyperbola where they're opposites like this one, or as I said before, you know, you're going to have 2 that go towards the same point. Either both of them are going up and both of them are going down. Now, how we know that is because we have x's on both the top and the bottom. And there was, I mean, technically what we should have done if we follow all the rules that we've done so far, we should check and see if there's anything that we can factor out. And there's nothing that, I mean, we could take a 2 out of the bottom here, but nothing's going to cancel with the top. All right, so whenever that's the case, then when you have some kind of fraction here, it's going to be either look like this first one, or it's going to look kind of like this one here, whether on both sides they're both going up or they're both going down. All right, so number 2, we're going to evaluate it at 1. All right, same rules. We are going to plug the 1 in. So we get 1 squared is 1 minus 1. There's our 0 on the bottom again. All right, so because of that, we got to try something different. All right, we could factor out the bottom, but there's nothing that's going to simplify with the top. So that didn't do us any good. All right, so then it's going to be one of these concepts here where you're just plug in points. All right, now the plug-in points part that I would do here is, we know because it's a fraction here, it's either going to look like this or look like this. All right, and we only care about the right side now. So we know that at 1, it's undefined. And then I would maybe plug in 3 points to the right. Okay, and I'm going to do 3 this time just to make sure that I don't make a math mistake on the way. All right, so if I plug in a 2, we get 1 over 2 squared is 4 minus 1 is 3. So this would be a 1/3. I plug in a 3. 1 over 9 minus 1 is 8. So 1/8. And then, I mean, technically, I could probably tell what's going on here, but we could plug in a 4 here. 1 over 16 minus 1 would be 1/15. All right, now, all of these are really small numbers, but all we are caring about at this point is we know that it's going to either go, as we get closer and closer to 1, we know that it's either going to go to positive infinity or negative infinity. All right, so this one, we have to tell as we are getting closer to 1, our numbers are getting bigger or smaller. At 4, we're at 1/15. At 3, we're at 1/8. At 2, we're at 1/3. These numbers are getting bigger the closer we get to 1. So then our answer would be positive infinity. Now, it seems kind of weird that when we're at all of these are less than 1, and we're saying that this answer is going to get all the way to positive infinity. Well, if you use your calculator really quick and you type in 1.01 for x, Jacob's going to do this for me since he's with me here. All right, Jacob, 1.01 squared minus 1 is how much? Say it again. All right, so he typed this in on the bottom. He got 0.0201. Now take 1 divided by all that, Jacob. And what do you get? 49.75. So we're only a little ways away from 1. And then all of a sudden, it's jumping to 49.75. If you put in, and we're not going to do this because you guys are smart kids, you can figure this out. But if we put in 0.00000001 in there, this would get to be a really, really, really big number. All right, so that's why we're just going to look at our numbers here. If they're constantly going up, it's going to be positive infinity. If they're constantly going down, then it's negative infinity. And that's all we're looking for here. And how we know this is we have this fraction here where we have either, and it's really going to be one or the other here. We're going to have 2 x's like we have here, and they don't have the same power. All right, so whenever that's the case, whether it's an x and just numbers down here on the bottom, well, no, for that one, that would be a straight line. But if it's an x squared over an x, or an x cubed over an x squared, it's going to look like this. Or over here with what we have, if it's 1 over x to any power, it's going to be one of these two. Now, from what I can tell from all the ones that I've done with this, I haven't found a shortcut to be able to tell if it's going to be this one or if it's going to be this one. So you're just going to have to trust your XY chart to be able to get there. All right. Number 3, the limit as x approaches 2 of negative x squared over 2x minus 4. All right. Now, this is the exact same graph as we had for number 1. So let me put this on here really quick. And what we basically found out was this is going to shoot up like this, and this is going to shoot down like this. All right. Now, this says we need to evaluate it from both sides. Well, when they're going in opposite directions like that, this is going to be a does not exist. All right, because to be able to get an answer, they've got to approach the same number from each side. So the only way we could get an answer out of this one would be if this side shot up also. All right, so I didn't mean to put the exact same problem outside of the plus or minus not being there, but it is what it is there. All right, so there's a quick example of one that doesn't work here. 4, limit as x approaches 1 from the right of negative 2x over x minus 1. All right, so first thing we do, we plug in the 1. We get negative 2 over 0. We've got to do something else. I don't really want to graph this, but we know at 1, it's undefined. All right, we need to evaluate it from the right side. So we're going to test out 2, 3, and 4 again. All right, so if we plug in a 2 there on the top, we get negative 4 over 1. So we get a negative 4. Plug in a 3, we get negative 6 over 2. So that'd be a negative 3. And plug in a 4, we get negative 8 over 3. All right, and if you need to flip this into a mixed number here, or change this into a decimal, all right, this would be negative 2.67. All right, now what we have to do, and it's really hard to visualize this from the right side, but the closer we get to 1, so actually we are reading this, if you make your XY chart like this, we're reading this from the bottom to the top. All right, the closer we get to 1, the smaller the numbers are getting, right? So we're at negative 2, negative 3, and then negative 4. Those are continuously getting smaller. So our answer would be negative infinity here. All right, and once again, the reason that we know that it's going to either be positive infinity or negative infinity, we have an x on top, x on bottom, all right, and we've got a 0 on the bottom here, we couldn't factor anything out. At 1, it's going to be an asymptote. All right, any questions with number 4 there? All right, last one then. Evaluate the limit as x approaches pi over 4 of tangent of x. All right, so you're going to have to do this with some of the trig functions also. All right, so knowing you guys, your first step is going to be, and it's totally fine, flip this into degree mode. So this would be 45 degrees. All right, and then you could do a couple different things here. All right, technically, you could use your calculator if you wanted to, and you could go, and remember, we have to evaluate this from both sides. All right, so I would go tangent of 44, and Jacob, you're going to get that for me, and tangent of 46. Tangent of 44, you got it for me? 0.9. Are you in degree mode or radian mode? 0.97? I thought it'd be a lot bigger than that. No, that'd be right. Never mind. I'm just a little slow today. 0.97. All right. And then tangent of 46. 1.04. Now, I probably skipped a step, didn't I? What is the very first step that we should be doing before we evaluate it from both sides? We should evaluate it at the point. If we evaluate tangent of 45, we would get a 1. All right, now this isn't necessarily wasted. I just completely skipped a step, which I shouldn't have. But if you're like, all right, I'm going to evaluate it from the left side, and I get something that looks like this. I'm going to evaluate it from the right side, get something looks like that. Those two are already really close to 1. Chances are the closer and closer it gets, it would be at 1. All right, and just a quick refresher, tangent, we would have an asymptote at 90 degrees and negative 90 degrees. And then we'd have our tangent line, it kind of looks like a cubic, that would go right through there. Okay, so that was an accidental mistake. I didn't mean to do it on purpose, but it was a good mistake to make because our first step always should be to plug it in. And if you get an answer, that's what the limit is going to be equal to at that point. All right, so keep that in mind as you do your stuff today. All right, but that's all I have for you. I kind of made it a little bit on the quick side. For some of these, I would probably expect some questions, but remember for these, your first step, like I skipped here, is to plug it in. If you get an answer, that's your answer. It doesn't matter if it's plus or minus or there's nothing here. That's just what your answer is. All right. If you don't get an answer, so you get something like this here, then you've got to do something else. Now, remember the first day we did limits, we did like x minus 1 over x squared minus 2x plus 1. All right, now this, if I saw this today, I would start to lean towards what we're doing here today. All right, but your next step should be, all right, I need to factor this, see if I can simplify this at all. And this would be x minus 1, x minus 1. And then those would cancel out. And it's still, you're going to still get a graph that looks like what we're doing today, but not always, would you? This one, you definitely would. So make sure that step one to limits, if we're going to make some steps here. Step 1, plug it in. If it works, then you're good. If you get something over 0, then you've got to do a next step. See if you can factor things out. All right, so factor it, go from there. And then if it factors out and you're able to evaluate then we go back to step 1 and see if you can plug it in and get an answer. If you still get something over 0, then you're going to have to, step 3 then would just be to look at the graph part of it. All right, look at the graph or the XY chart. All right, so that's really, if you follow just those 3 steps, I think that's it for the most part. We do have the special cases where, like, if there's If there's an absolute value, well, we're skipping to this step almost immediately. If it's a complex fraction where it was one of these, well, technically factoring and simplifying are the same thing. So this would be a step 2 thing, and then you plug it in. So really all of your limits here that you're going to do, it's following those 3 steps. All right, it just may look a little bit different there. All right, so any questions for me before I let you go here? All right, you guys have been doing better homework wise. Finish things up. All right, you do have a worksheet on Schoology. It's limit 6. Get that going, get it done right away, so that you don't start to have that mountain of homework. I realize it's not due until next week, but you've also got almost an hour before your next class, so you might as well use this time to at least get a really good start on it. And I would expect at least some of you to be able to finish that whole thing. It is a little bit longer today, and I will always put review problems in on that so that you can continue to really practice these 3 steps here that we talked about. All right, so any questions for me? All right, I'm gonna let you go. If you have questions, you let me know and we'll go from there. If not, you guys have a great weekend and I will see you next week.